we're going to actually go ahead and skip problem 2. Skip this problem. I'm going to put it on your final. I'm actually going to put this problem on your final exam. I'm just going to make a note here. So this will be on your final, just so you know. And we're going to actually move on to the next question here. So, whenever you see a kid in an IB problem standing over a cliff with their arm outstretched like they're getting ready to receive Holy Communion, what this means is that you have a situation where you're going to throw a stone upwards and it's going to land and hit the sea. So let's be clear. Right as the stone returns, its speed will be 8 meters per second. Note that the v at the top is 0, and the whole time the acceleration is equal to g. So we want the height, the maximum height reached by the stone. So here we go. We can say v squared equals u squared plus 2gs using the formula. So we reach a speed of 0 at the top. We started with the speed of 8 plus 2 times 10. And I'm going to say negative 10 since this, I'm actually going to define a as g, and since g is a downward acceleration, we're going to make this negative 10 in my notes right there. So we're going to have 64 equals negative 20 times s. And so we're going to end up getting here 3.2 meters equals s. And now here it says the time taken by the stone to reach its maximum height. So let's go ahead and get that. So we have v equals at plus u, or in this case that's going to be 0 equals negative 10 times t plus 8. So t is going to end up being 0.8 seconds. So it says the time between leaving Antonia's hand and hitting the sea is 3 seconds. Determine the height of the cliff. This is an interesting question. Let's be clear on what's happening. So let me draw a little sketch here. We're going to have the stone start here, go up, return, and then hit the water. And this total time is 3 seconds, but let's be clear. I'm going to take 0.8 seconds to go up, 0.8 seconds to fall down, and then here I'm going to have 1.4 seconds to hit the sea. Why? Because 0.8 plus 0.8 is 1.6, and 1.6 plus 1.4 seconds gives me a total of the 3 seconds of traveling that we have. So in other words, we have 0.8 to go up, 0.8 to go down, and then a remaining 1.4 to hit C. So with that in mind, let me try a little bit of a different approach. So we are going to say the height of the cliff is negative 1/2 gt squared plus, well, actually, let's be clear. So I'm going to write this formula. S equals 1/2 at squared plus ut. Now here's the deal. I fall the distance h, and that's going to equal negative 1/2 times 10 times 1.4 squared minus the 8 times the 1.4 that we spend traveling. So with this in mind, we're going to say negative h equals negative 5 times 1.4 squared minus 1.4 times 8. It's going to be minus 11.2. So h ends up being a total of 21 meters.